Okay, so just like I promised, here's the part 2 of solving equations absolute value. So for this one, we're going to look at the bottom of page 21. So for number 6, we have absolute value 20x equals 4x plus 16 in absolute values. So what makes this one different is that you have an absolute value on both sides of the equation, which means it is technically actually solved. It's isolated. We can solve this very easily. Now, just like before, we have to do one positive, one negative. So the positive side is going to be 20x equals 4x plus 16. So that's not going to change. So let's go ahead and just solve it. Subtract the 4x across, and you get 16x equals 16, so x equals 1. Okay, now plug in the second one. So the second one is going to be 20x equals negative 4x minus 16. So for this particular one, I'm going to take and I am going to add 4 across. So I get, I think I'll put a minus there. So I'm going to add, I get 24x equals negative 16. So then I divide it on both sides by 24. So x equals negative. Now they both have an 8 in common. So 2/3. So the first thing I'm going to do is check these. So now what's really important with this one is you have to check both of them. Sometimes one works, sometimes both works, and sometimes neither one works. And when we get into square roots and radicals, when you get into Algebra 2, guess what? You're still going to have to do that check step to make sure it works. So let's do a quick check step. With the first one, it was just 1. So 20 times 1 is 20, and then 4 times 1 is 4 plus 16. So it looks like I have 20 equals 20. That one checks out, no problem. So let's look at the second one. So the second one is basically 20 over 1 times negative 2 over 3. So it's going to be negative 40 over 3 in absolute values, which we know will make it positive. And on the opposite side, I am going to have in absolute value 4 over 1 times negative 2 over 3. Whoops, that right there should have been a plus and not an absolute value. And what I'm going to do is go ahead and put 16 out of the denominator 3 because we know this is going to end up becoming negative 8/3. So what we really need to do is go ahead and come over here and say, okay, if I make that into a 3, 3 times 16 is 48. If you don't remember how to get common denominators, remember with fractions, if you want to change the denominator into something, you have to multiply that number, which is 16, the numerator, by the same thing. So what's going to happen is those two things are going to combine, and I'm going to end up getting 40 over 3 on the left, positive, and negative 8 and positive 48 is going to end up being 40 over 3. So this one also checks out. So that means you have two answers here. We have negative 2/3 and positive 1. If it hadn't checked out, then one of them would not have been the solution. So a little more complex, but the same concept. So let's look at number 7. Number 7, we have p plus 4 equals p minus 2. So same thing, we drop the absolute value for the first one and just make them equal to each other. The second one, we're going to keep the left side. If you notice, I'm always keeping the left side the same, and it's the right side I'm picking on. Maybe because they can handle it better, I don't know. But on the second side, you're going to end up making that negative 2 into a positive 2 because a negative negative makes positive. So the next thing I'm going to do here is solve. So watch what happens with the first one. You subtract p from both sides, and the p drops out, and you're left with 4 equals negative 2, which is not a true statement. So I started to write statement beside it. So it's not a true statement, meaning that that one does not have an answer. So let's see what happens with the other one. So I'm going to add p across. So I get 2p plus 4 equals 2. So now I'm going to subtract 4 across, and I get 2p equals -2, or p equals -1 when you divide by the 2. We still have to do the check step on the second one. Just because the first one worked out didn't work out doesn't mean that the second one won't work. So let's check it and find out. So we're going to have -1 plus 4 in absolute values equals -1 minus 2. So it looks like I'm going to have absolute 3 equals absolute -3, which, since they're in absolute values, ends up being 3 equals 3. So my only answer I have is -1. Okay, so here's the thing. I want you to try number 8 and number 9. Yeah, I know they're a little bigger, but it's literally the same concept. If you don't want to do the check step, hold off, and then you can do it with me on the second part. So pause the video. When you come back, 8 and 9 will be posted. Okay, are you ready to compare results? So the first one was 4q plus 9 equals 2q minus 1. We wrote it into two separate statements. 4q plus 9, 2q minus 1, and 4q plus 9 equals -2q plus 1. We worked them out. The first one ended up being -5. The second one was -4/3 when you reduced your fractions. So that part we should have. Check step, which I like to say is proofs in the pudding. As you can see, I ran out of room on the second part, but we got there. First one with the -5, pretty straightforward. Basically what we're doing here, we check out, we get 11 equals 11. The second one, I held off putting the +1 until I got down to the second stage. So if you're wondering where the other +1 is, I ran out of room and I'm sorry about that. So we have 4/1 times -4/3, which gives me -16/3. Plus, now I converted the 9 into a fraction with the 3 in the denominator. So once again, you multiply 3 times the 9 gives me 27/3. Subtract 16 and 27, I got 11/3. On the other side of the coin, over here, we have -2 times -4 gives me -8/3, or +8, sorry, over 3. Plus, 1 is the same as saying 3/3. So 8 plus 3 is 11, so 11/3 equals 11/3, and once again, both answers are correct. So in number 8, the -5 and the -4/3 are the two answers that you should have gotten. If you got it, awesome. This was a difficult problem, but it wasn't above the level you could do. Now let's look at the last one, number 9. So for number 9, same concept as number 7. What happened there was on the first part, the 2x minus 7 and the 2x plus 9, the 2x is canceled out, leaving an untrue statement. -7 is not equal to 9. So therefore, that one kind of drops out of the race. So we look at the other one. So the other one does make a true statement. We get x equals -1/2. And if you don't know where the half came from, remember, -2/4 reduces into -1/2. Now, the check step's pretty straightforward. I took 2 and put it over 1 times the -1/2, giving me -1. Drop down the -7, giving me -8. On this side, same thing. 2/1 times -1/2 gives me -1, plus the 9 gives me +8. When you drop them out of the absolutes, it's 8 equals 8. Everybody wins. The -1/2 then is the correct answer. All right, folks, this one was a little tougher concepts. There's nothing above what you can do. Great job on all of your efforts. Let's take a break. And remember, these are just to help you out so when you get into the next level, you will be ready. Awesome job. Until next time, have a great evening.